So students, today again you had two questions of calculus and both from integral. One is of course inequality, which we normally use, or the type of questions which we may expect from the inequality part of integral, definite integral, and second one is on limit as sum. Let's start. So see, given p is equal to 0 to pi by 4 and it is sine of tan x dx, okay, and q is our 0 to pi by 3 tan of sin x dx. Okay, now see, since we know we have to compare p by root 2 minus 1 by root 2 and q by ln 2. Okay, larger or greater is another thing. See, so first thing is 1 minus 1 by root 2. Root 2 minus 1 by root 2 is how much? So it's 1 minus 1 by root 2. And integral is from 0 to pi by 4. That means we need to have sine pi by 4 or cos pi by 4 within integral, then only we will get as 1 by root 2. Okay, so now how I initiated it, I said okay, that we know tan x is greater than x when x is obviously greater than 0 and between pi by 2. And here in this integral, the limit of x is of course between 0 to pi by 2, it's 0 to pi by 4, so it gets satisfied. Now in the interval x belonging to 0 to pi by 4, can anyone tell me sin x is an increasing or decreasing function? So we know sin x is an increasing function. Yes or no? है ना बच्चे? मानते हैं सारे बच्चे? So it's an increasing function. So that means if I apply sine both the sides, since it is an increasing function, doesn't make any difference. So this gets this. So that means your p, which is 0 to pi by 4, is greater than 0 to pi by 4, and this is nothing but minus cos x 0 to pi by 4, which is 1 minus 1 by root 2. Okay, so this is like 1 minus 1 by root 2. Okay, so p is greater than 1 minus 1 by root 2, so that's the answer. So that's one answer here. Of course we need to get for q also. Now q is what? Q is tan of sin x. Fine, so q is from 0 to pi by 3 tan of sin x. So applying the same logic here, tan of sin x dx, exactly same, but here what happens is sin x is less than x when x is greater than 0. So then what? So that now tan again is an increasing function in the interval 0 to pi by 3, so tan of sin x is less than tan x. So q is less than 0 to pi by 3 integral of tan x dx, which is nothing but less than ln mod sec x 0 to pi by 3, and that gives us ln 2. So q is less than ln 2, so that should be the answer here. So that was the first question based on inequality in definite integral. Now the second question is f of n is given to be n plus 16 plus 5n minus 3n square, 4n plus 3n square, I believe 4n plus 3n square. Okay, now it's 32 plus n minus 3n square, 8n plus 3n square, then it is 48 minus 3n minus 3n square. This is I think 4 3 12, yeah, it's 12n plus 3n square, and so on and so on. Write its general term, tr. So in denominator there is no trouble, 3n square plus 4nr. मानते हैं सारे बच्चे? It's multiple of 4, 8, 12, 16. It's a multiple of 4. Okay. In numerator, minus 3n square is fixed. 16, 32, 48 is a multiple of 16, 16r. Plus 5n, 4n, minus 3n. It's an AP. 5n is the first term. R at term 3, the r minus n into minus 4n. What do we get? So we get 16r plus minus this is plus 4nr, okay, minus 4nr to 12nr, and then this is plus 4r, fine, and then this is plus 4n, I'm sorry, plus 9n, really sorry, 5n plus 4n. Just a minute, bachcho. So this would be, let me get it clean. Yeah. So this is 9n minus 3n square upon, I think those many terms we have, 3n square plus 4nr. Okay. So 4nr minus 3n square. Okay. So if I add here 6nr plus 9n, we get minus 3nr plus 4nr. 3n square plus 4nr. Okay. So 3n square plus 4nr. So finally the rth term is 16nr plus 9n upon 3n square plus 4nr minus 1. N gets cancelled. So it's 16r plus 9 upon 3n plus 4r. Fine. So that's it. So what do we need? We need the limit as n tends to infinity, minus 1. Okay. So if I take 1 by n common from here, then there's some problem occurred. Just a minute. 3n plus 4r. It's okay. R by n. There should be some mistake here. Just a minute. Okay. So 4nr plus 3n square. It's 4nr plus 3n square. In numerator is 1632. So it's 16r. 16r. Okay. Then it is minus 3n square. Fine. 5n. So if I write this as the, so 5n minus 4nr. Did I miss that term? Plus 4n. Minus 4nr. Okay. So this went with that. So 16r plus 9n. Okay, yeah, that's a mistake. It's 16r plus 9n, and that's it. Okay, sorry. Because we need to get 1 by n. है So that was a mistake. Because see, limit as sum के form में आना है, we need to have 1 by n. Oh, I think we will get it. Let me try it quickly. So now it is minus 1 plus, you take n common, 1 by n, 16r plus 9n divided by 4r plus 3n. Now limit n tends to infinity. Okay, and then when you apply it to it, so minus 1 is independent of it, of course. So it remains minus 1, doesn't matter. Okay, so I am not putting it over here. So minus 1 is minus 1, and limit n tends to infinity gives us minus 1 plus limit n tends to infinity 1 by n divided by n, both the things. So 16r by n plus 9 upon 4r by n plus 3. Now we know it's an integral form. So minus 1 plus 0 to 1, 16x plus 9 upon 4x plus 3. Now you just solve it. Okay, so it will be like minus 1 plus 0 to 1, 4 times 4x plus 3, 12. So minus 3 upon 4x plus 3 dx 0 to 1. So upon 4x plus 3. So that gets cancelled. So this is 3 plus 1 by 4, rather minus 3 by 4 ln of mod 4x plus 3, and that should be the answer, 0 to 1. So the answer is 3 minus 3 by 4 ln 7. Is that an option? 3 minus 3 by 4 ln 7 by 3 is the answer, I suppose. एक बार आप इसे check कर लीजिएगा, ठीक है? So that's it. Those were 2 questions on calculus for today.